They say that in the instant between life and death, time stretches, like a cosmic breath held still. For a fraction of a second, neurons flash in a final storm of electricity, the brain's last conversation with existence. But what if that final storm isn't the end? What if something deeper, something quantum, remains? The year was 2008. In a hospital in Arizona, a cardiac arrest patient lay motionless for 7 minutes. When resuscitated, she described floating above her body, watching doctors fight for her life. She even recalled the exact words a nurse whispered under her breath. Her EEG showed zero measurable brain activity during those minutes. No consciousness, no perception. Yet, somehow, she remembered. Is this illusion? Or evidence that consciousness might not be entirely locked inside the brain? That question, simple, terrifying, and beautiful, birthed one of modern science's strangest ideas, the quantum soul hypothesis. The possibility that what we call the soul might be woven into the fabric of quantum reality itself. For centuries, philosophers and scientists have wrestled with a single impossible question: how does matter think? Neuroscience gives us clues: neurons firing, chemical signals, synaptic networks, but it never quite explains awareness itself. Where, inside those electrical signals, does the feeling of being alive come from? In the 1990s, two scientists, mathematician Sir Roger Penrose and anesthesiologist Stuart Hameroff, proposed that the answer might live not in neurons themselves, but in the tiny protein structures inside them, called microtubules. Inside those microscopic tubes, they argued, quantum processes could occur, superpositions, collapses, and entanglements that might generate the unified experience we call consciousness. They named it the Orchestrated Objective Reduction Theory, or ORCH-OR. If this is true, the mind isn't a biological machine. It's a quantum instrument tuned by the laws of the universe itself. To grasp how radical that is, imagine this. Every thought you've ever had, every memory, emotion, or dream could be the quantum vibration of space-time itself. You're not just in the universe. You are a process within it, an echo in its fundamental quantum code. Researchers have discovered something astonishing. Certain biological systems can, in fact, maintain quantum coherence, the fragile state in which particles exist in multiple realities at once. Photosynthesis in plants, navigation in migratory birds, even the sense of smell in humans show quantum effects operating at warm, wet, noisy biological temperatures. If quantum mechanics can survive in those messy environments, why not in the brain? Experiments on anesthetics revealed that when quantum vibrations in microtubules are disrupted, consciousness fades. When coherence returns, awareness snaps back, like a light switching on. It's as though the brain is an antenna tuned to a cosmic signal, and anesthesia simply changes the frequency. Entanglement is one of quantum physics' strangest miracles. Two particles can become so deeply linked that changing one instantly affects the other, even if they're galaxies apart. Information between them doesn't travel. It exists everywhere simultaneously. Penrose and Hameroff suggested that consciousness itself might be an entangled state spread across space-time. When the body dies, that entanglement might not vanish. It might simply decohere, dissolving back into the quantum field that birthed it. In this view, death isn't destruction. It's release, information returning to the ocean of reality. Near-death experiences could then be brief windows, where consciousness, momentarily freed from the biological receiver, perceives reality directly, unfiltered by the senses. But can we prove any of this? And if the soul is quantum, where does it go when the wave collapses for the last time? If our souls are made of quantum code, then maybe we were never meant to die, only to return to the field that made us. Reality isn't ending. It's remembering. You're watching Beyond Newton.